Hi everyone, this is your math guru. In this video, I'm going to show you how to apply your sine rule, your trigonometric ratios, and your Pythagoras theorem to solve the following problems. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. In the first example, we have ABRQ is an aerial view of a plot of land where R1 equals to theta, A2 equals to 2 theta, and angle Q equals 90 minus theta. The line QR equals to a unit. Determine AR in terms of theta and A, and hence show that the line AB equals A over 2. We're going to start with the first part of the question that says determine AR in terms of theta and A. To determine line AR, we're going to use the triangle AQR as highlighted below. And because it's not a right angle triangle, we're going to use either of sine rule or cos rule. We've been shown from the equation or from the question that the line QR is equal to a unit, so I'm going to slot that in the diagram. So therefore, using a sine rule, which states that the line AR, or the ratio of the line AR over the sine of the angle facing AR, and that's 90 degrees, minus theta, is equal to the side A over the sine of the angle facing A. That's 2 theta. You can see the angle facing A is 2 theta, and you can see that the angle facing your line AR is 90 minus theta. If we cross multiply, we have AR multiplying sine 2 theta equals A multiplying sine 90 degrees minus theta. Remember, we have to find AR. So therefore, dividing both sides by sine 2 theta, we have AR equals A sine 90 degrees minus theta over sine 2 theta. Using your co-function, we have sine 90 degrees minus theta becoming cos theta, and using the double angle formula, sine 2 theta becomes 2 sine theta cos theta. That's using your trig identities. We have cos theta dividing cos theta. Therefore, the value of your AR will be A over 2 sine theta. For the next step, we have to show that the line AB equals A over 2. To do that, we're going to use the triangle or the right angle triangle ABR. I'm going to highlight that as shown. And because it's a right angle triangle, using our trigonometric ratios, we need to determine the trig ratios to use. So if you look at this right angle triangle, the line AB facing your theta as shown is our opposite. The longest side or our hypotenuse is tagged, and the last side is our adjacent. We already know the value of our AR, which is also our hypotenuse. We are looking for the side AB, which is our opposite, and the trig ratios we'll use is sine theta equals opposite over hypotenuse. Putting in the necessary parameters, we have a sine theta equals the opposite, that's your AB, over the hypotenuse, that's AR, and that is the same as A over 2 sine theta. And that's the same. Simplifying, we have that as 2AB sine theta divided by A. Remember, we have to make AB the subject of formula, so we start by dividing both sides by sine theta. We have 1 Or we can start by cross multiplying. If we cross multiply, we have a sine theta equals 2ab sine theta. Dividing both sides by 2 sine theta, we have 2 sine theta on your right and 2 sine theta on your left. What happens is we have sine theta dividing sine theta. We have 2 dividing 2 and sine theta dividing sine theta. Therefore, we are left with a over 2 equals 2 ab, which is the same thing as ab equals a over 2. Let's look at the second example. In our second example, we have in the sketch below, AB is a vertical building. BCD are points on the same horizontal plane. The angle of elevation of C to A, as shown at the top of the building, is theta. Angle DBC equals to 30 and angle DCB equals to theta. The line BD equals to 12 meters. We have to show that the line BC equals 6 cos theta over sine theta plus 6 root 3. We are going to use the triangle BCD as highlighted below. Before we do that, we're going to start by looking for the angle at D. Remember, the vertical line AB is going to form 90 degrees to the horizontal, but if you're using triangle BCD, the angle at B plus the angle at C plus the angle at D equals 180 degrees, the sum of angle in a triangle BDC. Therefore, we know the angle at B to be 30 degrees. Angle at C has been given as theta. We have to find angle at D. So making D the subject of formula, we have therefore angle D equals 180 degrees minus angles 30 degrees plus theta. Going back to the question, we have to show that the line BC equals to the expression as shown. So we're looking for what the value of BC will be, and using our sine rule, we have the side BC over the sine of the angle facing BC, and in this case that's D, and we have that as sine 180 minus 30 plus theta, close bracket. I'm going to extend my fraction bar. That is equal to the side BD, which is 12, over the sine of the angle facing BD, which is theta. So we have that as sine theta. If we cross multiply, we have BC sine theta equals 12 times sine 180 degrees minus 30 degrees plus theta. If we simplify, we have that as BC sine theta equals 12 sine, because that's found in the third quadrant. A correction that's found in the second quadrant, and the value of sine in the second quadrant is positive, so that becomes sine 30 degrees plus theta. Also, 30 degrees plus theta, we can take that as sine A plus B. And using our trig identities, we have BC sine theta equals 12. If we expand that, we have that as sine 30 cos theta plus cos 30 sine theta. I got that from, I have sine A plus B equals sine A cos B plus cos A sine B. So simplifying and using our special angles, we have BC sine theta equals 12 multiplying sine 30 degrees, that's half, cos theta plus cos 30 degrees will give us root 3 over 2 sine theta close bracket. If I expand using my 12, I have BC sine theta equals 6 cos theta plus 6 root 3 sine theta. Now I'm going to divide both sides by sine theta, and what that means is, or I'm going to divide each of the terms by sine theta to have my BC on my left hand side. So therefore the value of my BC equals 6 cos theta over sine theta plus 6 root 3 sine theta over sine theta. Sine theta divided by sine theta, that's therefore the value of my BC equals 6 cos theta over sine theta plus 6 root 3, which is the same as what we have in our question. Thanks for watching. Bye.